Welcome to the Most Dangerous Device radio show, where we discuss free energy and over-unity devices and their impact on society. Today's guest is John Rohner. John is the CEO of Inteligentry, a company that consists of 12 people who research, manage, and administrate the Plasmic Transition Process patent to various companies who are currently building noble gas engines using this technology. This patent describes a process for powering an engine consisting of one or more cylinders containing a mixture of inert gases. When these gases are excited using this patented electrical process, the pistons are pushed at a constant rate of speed by the transition of those inert gases into a plasma state. This process also allows for the gases to fall back into their normal gas state after moving the piston and thus powering the engine with no exhaust and no other combustible fuel. Very little electrical power is required to convert the gases into the plasma state, and because of this, the noble gas engine, specifically Inteligentry's patent of this process, is considered by this radio show to be an over-unity device, and so we now welcome John Rohner to the Most Dangerous Device radio show. I want to thank you for joining us today on the Most Dangerous Device, John. What got you interested in the noble gas engine?
Well, really quite easy. In the early 80s, my brothers were involved with Joseph Papp, and my brother Tom, who I designed electronics products for, happened to send me a letter when I was out in California and said, I've got this mechanical controller. Can you turn this into an electronic device for me? And I did. And then, of course, I kind of forgot it because I was busy as hell doing whatever else I was doing there. And then about 4 years ago, my brother Bob started going out trying to collect money to revive the engine, and he asked me if I'd be a part of it. Then I got a chance to see what the hell he was doing for real, and quite honestly, he was bringing in all kinds of these people from CEI that I never heard of. And so one day I said to him, I said, well, look here, I don't know who these people are, and I don't know what they got to do with anything. And he turned to me and he said, well, these people have been working since 1989 on this engine, and if anybody's going to figure it out, they'll figure it out, and you don't need to worry about it because, after all, you'll never be able to figure this engine out because it's impossible for you to do. Well, I got to tell you, I have spent 40 years doing impossible. And when someone says to me, it's impossible for you to figure out how to make an engine like this work, well, guess what? It took me 3 months to file the patent. And between that time, I actually took an approach to finding out how the engine worked, which was a lot like you take in any new design job, and that is you go back and find out how it's controlled, and you look at what is the controller actually doing. And in this case, since I already had a schematic for the controller and a definition of it, I just went back to that and I started looking at what it was doing. And then all of a sudden it hit me exactly what it was doing. So I've got friends in the fusion and fission and plasma parts of the world. And so I sent them all out a definition of what I thought was going on in this cylinder. And, of course, most of them came back with, are you playing with the Papp engine? That's a scam. Get the hell away from it.
Right.
Okay, and then about 2 days later, I got an email from one of them going, you know what? This kind of transfers areas that we don't normally transfer now. Because, you see, when I left physics in 1962, the world was not split like it is now. The fusion people don't know anything but fusion. The fission people don't know anything but fission. The plasma people don't know anything from plasma. So when you present them with a problem that covers all three areas, they first come back at you and go, nah, this won't work. And then they come back and go, well, yeah, this might happen this way. And so I got them all talking to each other finally, and within about 3 weeks we had a math model that we could run and prove that, yes, indeed, you could do this. And from there on out, it was just simply sit down, write up what you needed for a patent, get it in, and from that simulation, I also knew how and what the control features had to be. So that's why our patent has to do with the process, i.e., how does this happen, and the control. And I also read the PAP patents, and I realized from the PAP patents that he was using 2 radioactive elements in there, and the only reason he was using them was to get around having to give it a higher voltage of electricity. And so in our process, we use a higher voltage electrical arc than he does, but we don't use any radioactive material. And you're going to love this. We replaced the strontium in his engine with a strontium impregnated welding rod.
Okay, now I don't know what strontium is, so you're going to have to educate me.
Oh, strontium. I don't know. I get it wrong half the time too. So it's just a radioactive element.
Okay, so this engine does not use radioactive elements at all?
Not at all.
Awesome.
Not only that, but after we got the first engine working, I started looking at gas flow analysis to see what was going on with that. And then I discovered that in the videos from the PAP engine, when he took the cylinder apart, there's a kind of a brownish dust inside, and that's actually the residue of 2 helium atoms fusing. But it also meant that he was doing mass murder in there.
Ah.
Because you don't build up this much stuff if you got any efficiency.
True.
So I went back and did some flow analysis, and we did a few other odds and ends, and we now have an engine that knows when that fusion event happens, turns off the impetus for it, and so at the end of any runtime, you can take the head off and find not a single one piece of that dust.
Oh, that's awesome.
So that gives you some idea how much more efficient we've got.
Right.
And then we also did a flow analysis on the gas flow in the cylinder, and we reshaped some things in order to make that more efficient. To give you some idea, the PAP engine, if you sit down and run the equations, will run about 4.5 months.
Okay.
Well, we expect the current engine to run for nearly 2.5 years.
Wow.
Without any fuel being added.
You know how amazing that fact is.
Well, the thing is, okay, if you sit down and look at physics, what happens is, okay, you come up with a thing called recombination. And the way that the triggering event happens, because we stop that as soon as it happens, we catch it in kind of a mid-state. It can, at that point, actually recombine and recover as if it were a fission event.
Wow.
And that's what we call recombination. We have some theories that say that we might have as much as 98% of that. But we know that we're up over 60% at the moment. And the reason for that is we do have an older generation engine that's up over a year and 9 months without refuel now.
So I have seen the videos for Daniel Roberts, and he explains about proton rings and key ring atoms. Do you believe that this is what is going on inside?
Well, actually, the problem you've got is there's nothing magic going on in this engine. Every single person in the whole world has seen this happen at least once, unless they're blind.
Okay.
Because almost everyone has seen lightning.
Right.
Lightning is simply a good example of the process. You have 2 opposing poles that ionize the gas between them, and then an electron charge comes through that ionized gas and converts the gas from a gas to a plasma. The side effect of that transformation is visual, so that's the lightning you see, and the expansion of the gas from a gas to a plasma creates the sound wave that you hear for thunder.
Right.
There is nothing at all magic about the process.
So in essence, you've got an engine that harnesses the power of lightning.
Yeah, technically you could sit down and think about it that way, because the way the engine works is that we ionize the gas at a point where the piston is at top dead center, more or less.
Right.
And then we set off a fusion event so that we get a jolt of energy, and the fusion event takes 200,000 volts to happen.
Whoa, that's pretty high voltage.
Well, yeah, but we have 4 electrodes at 107,000 volts feeding it.
Okay.
Anyways, what we need there is just a big kick.
Right.
And the kick happens, and boom, you have a gas that's now set to go into a plasma, and it goes into a plasma. The plasma always does exactly the same thing as the lightning does. It expands. In our case, it expands 5 to 1.
Right.
Therefore, 100 cc's creates 500 cc's of a cylinder.
That's an incredible amount of power.
And, by the way, for your own information, it always does it in exactly the same amount of time. Whereas the elapsed time that it takes to convert to a plasma is always the same.
Wow. I also read that there's no heat or very little heat in this process?
That's true in a summary view.
Mm-hmm.
When the gas turns to a plasma, it does create heat. But when the gas reverts from a plasma back to a gas, it creates a vacuum, and because it's a balanced thermal event, it takes back the heat. So, in summary, you're not generating any heat.
So where do you think the energy is actually coming from?
It's coming from a natural function of the gas, that is the transition of the gas from a gas to a plasma. Plasma is a fourth state. You are aware you have solid, liquid, gas, and plasma.
Yes, I'm aware of that.
Well, just like steam is created from water, plasma is created from a gas. And in our case, we use 3 gases that are active. The helium is used to get the fusion.
Okay.
Because it's not explosive like hydrogen.
Okay.
And it sets off the neon, which sets off the argon.
Okay.
Boom, 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 and it's done.
Okay.
And quite honestly, it's just almost exactly that simple.
Well, it may sound simple, but actually putting it into practice is probably a little bit more difficult.
Oh, yeah. The difficult part of it is to control it. Because remember I said earlier that the conversion of the gas always takes exactly the same amount of time.
Right.
Well, knowing that, then you know that the engine can never have any speed more than that particular rate.
Right.
But the challenge now is, how do you speed that up? Well, if you've got something with a constant and it's creating a specific volume in a cylinder, then what happens to the cylinder if you make the diameter of the cylinder smaller? Well, the cylinder has to get longer.
Right.
But our stroke doesn't get any longer, so now we don't use the whole length, we only use a part of it.
Okay.
So in reality, we actually don't create a plasma, we actually create a pseudoplasma.
Okay.
Because we turn it off before it completes. And in order to get this cylinder smaller, we use a trick that the fusion guys have been using for years, and that is they control their plasmas with an electromagnetic field.
Okay.
And we do the same thing. We actually create a virtual cylinder within the cylinder that gets smaller and smaller and smaller as faster the engine goes.
So it's like a coil or something that contains the gas.
Right. Well, like I said, it's very much like a steam engine with a movable outside wall.
Wow. The reason for this broadcast is to educate the public of the existence of over-unity devices, or basically free energy kind of devices that produce more energy out than in.
Well, for one thing, okay, it's not free energy, just like any other device, it's not free energy. You do have a depletion. There is a depletion rate, or we'd be able to run forever on the same fuel.
Okay.
And you want to chuckle. If you go back and read the PAP patents, you'll find that Pap put in these patents that he was going to feed electricity from one cylinder to the other cylinder to make the other cylinder work.
Right.
And then back to the first cylinder. This was his way of trying to make people think that he was doing a perpetual motion machine.
Okay.
Quite honestly, that doesn't work for nothing.
Okay.
You can't get enough energy from the piston coming back up through the coil to do anything for the coils on the other cylinder. Also, one of the things that we're in the process of doing is that we are going to have injection molded pistons here within the next couple months. So there won't be any metal running in the middle of the coil anymore.
Okay.
And that has been a kind of a problem because the metal piston that runs through the coil creates, or can create, a problem, and we actually have to keep a 9-volt level on the coil just to keep that from giving us any feedback.
Oh, I see.
But anyway, yeah, you're right. I mean, the process itself is fairly easy. How you control it is a whole different ball game. And of course, we've got that now down to a science. And I probably sound like it's a lot easier than it really is because I'm kind of used to it. So it's, anyway, I'll get back to your questions. How's that?
Okay, that's fine.
But that's pretty much how it all works. Pretty easy. No intake, no exhaust, no heat. Costs you about $1 a year to run. Worst case.
That's definitely affordable.
And the other thing is that's interesting is that the engine is not like a combustion engine load-based. In other words, whether you've got a 20 kilowatt load on it or a 500 kilowatt load on it, if the engine's running 1,800 RPMs, it's going to run exactly the same amount of time.
Mm-hmm.
Because it's based on the repetition rate of the piston coming up the cylinder.
Right.
In other words, if it runs 2,300 RPM or 2,800 RPM, it'll run maybe 2 or 3 weeks less than if it was running at 18.
Right.
And, of course, the other thing you have to remember about the engine is that it develops power unlike what people are used to because there's the same amount of pressure on the piston at top dead center as there is at bottom dead center.
Wow.
So it doesn't just give you power for the first 20% of the stroke. It gives you power for the whole stroke. And, of course, when it turns into a vacuum, you can't get power from a vacuum, but the other side of the coin is there's no resistance there either. So the other piston now doesn't have anything to push.
Are there any videos showing this engine actually working?
Well, there's plenty of videos of the 1982 engine working, and there are no videos at all of this engine working. Because, for one thing, no one that we're licensing the technology to wants to have anyone in the world know about this until we're ready to announce it and they can be a part of the announcement and people can see that they've got real products and they've got stuff to sell. Whereas there's no reason to publish a current video because, for one thing, why do we care who sees the video? It's just what we want is we want everyone that's making an engine. Now, understand, we don't manufacture engines. We license the technology to people who can manufacture engines or people who want to put the engine together into an end product. And, of course, if you're putting the engine into an end product, you want to be there when the whole thing is announced because that gives you a nice advertising advantage. And if we went public with the engine before that, then all of the advantage to anyone who is doing a new product or anything else goes away.
How can experimenters prove that this phenomena really exists, though?
Well, we've got a little kit called Popper that people can build and fuel up and watch a piston move.
Okay.
If they want.
And how much does that cost?
Well, we sell the electronics and the high voltage coils and all the rest of that for about $350.
And that's everything you need to prove this technology actually works?
Well, the mechanical part of it, the tube that you're going to use and the piston you're going to use and how you're going to, we do this with a bed spring because all we're interested in is seeing how much power we get from any particular fuel mixture.
Okay.
I mean, if you're going to want to drive some kind of a crankshaft or something like that with it, then you're going to have to redesign the mechanical piece. We give you a complete set of plans for everything that we do.
Uh-huh.
Now, how you take that and modify it to do what you want to do, that's up to you.
Okay.
But what you do get is all of the electronics ready to go, so that all you have to do is push a button and it'll do what it needs to do. And we do include the special coil that converts from 12 volts to 107,000 volts.
Well, yeah.
And we put those in the kit as well. So you have a complete electronic set.
Okay.
But you're going to have to build your own mechanical side.
Okay. All right.
But we give you all of the instructions on how to do that and all the drawings and everything else for what we've got so that you can sit down and, we don't know what an experimenter is going to want to do with it.
Right.
So it wouldn't do us any good to send you a complete unit, because you're going to get it and you're going to go, okay, what the hell do I want to do this, right? So we'll send you a complete set of everything you need in order to tinker and make something function.
Is there a limit to how many times the gas can be excited?
Well, yeah. It's about 3 years. There is a depletion. You're going to lose a couple atoms every once in a while.
Okay.
At about 3 years, the engine is going to start to lose its punch.
Okay.
But we get around that by actually putting in an automatic refueler.
Oh, okay.
The master controller actually can tell from the event signature where it is in its current decay mode, and it will just put a squirt into the block, and that will refresh the whole engine. Mm-hmm. The cylinders for refuel will probably end up on supermarket shelves in Walmart and everything else for about $7 a copy. They're just a little 4-inch by 1.5 inches, like a paintball cylinder. Mm-hmm. We expect those to sell for about $7. But if you put one of those on the engine, we expect it to run more than 7 years.
Wow. That's phenomenal.
Yeah, because all this time it can be turning a 20 or 30 or 50 kilowatt generator to keep your house up, or a 200 kilowatt generator to keep your dairy farm up, or whatever. We have a friend out in Oregon who's an experimental aircraft guy, and he is waiting because he wants one of our engines. He's already converted one of these aircraft over with a porta potty, a microwave, and a fridge. He's planning on going around the world twice just for the hell of it.
Oh, that would be fun.
And I asked him, I says, why are you going to run twice? And he says, everybody else had done it once. So you got a lot of people with open minds and ambition.
Well, what are the implications of the technology as it applies to power generation? What do you see in the future for this?
Well, power generation is only one piece of it. But from power generation standpoint, we're talking now with small towns that have got tornado generators in them. How would you like to live in a small town, say 10,000 people, and have the city have a water department, a garbage department, and a power department, no link to the grid, and have your yearly electric bill be $200 per house?
That would be fantastic.
We have a networked system that we've been working on with the Canadian electric company. They're going to use it north of the Arctic Circle. But we can take any number of generators and put them together in a load-based network. That means as load comes up, it brings in generators. As load goes down, it takes them out. The beautiful part about using a network system like that is that it's fail-safe. You can lose a generator, but you don't lose the power. Mm-hmm. So we over-design it by about 20%, and that way you can never be without power in any given small town. And by disconnecting from the grid, you'll also take the load off of the coal, oil, and natural gas generators that are burning up the oxygen in the air while you're at it.
Yeah.
Now, another application of the engine that's good for power is you've seen the Nissan Leaf and the Mitsubishi electric cars.
Yes.
These have to be plugged in the wall.
Right.
And everyone says, well, these are green. Well, the fact of the matter is they're not green. When you plug that car in the wall, you're drawing power from some generator, nuclear, oil, gas, or something.
Coal.
That's got to be running to do that. And what we're looking at now is we're looking at putting a generator on the front of one of our engines, ripping out all those batteries, and dropping that into the front of an electric car, and giving you something that you never have to worry about plugging in again. And we'll run, if we took one of these engines and stuck it in the front of your car right now, you could drive 155,000 miles nonstop.
Wow.
But think about how that makes a car happen now. That's another form of power. Then you've got light aircraft, mm-hmm. and beyond that you've got fishing boats, yachts, that kind of whole environment. And you've got what the oil companies are talking about doing, and that is using the engine as replacements for their oil well engines. And also, we've got a 6-cylinder engine coming out in about 8 months that'll put up 1,100 horsepower that's going to be absolutely perfect for drill rigs. How would you like to go to work on a drill rig that doesn't have any fuel or any spark in the driving engine?
Well, I didn't think that you guys were into the manufacturing part of it.
We're not. we design engines, and we design them with our manufacturing partners.
Oh, okay.
So what I'm telling you about is basically what they're going to be manufacturing. We only get involved with it because we have to do controllers, and we have to verify that some of their parameters are going to work properly for them. And the six-cylinder engine has been a priority. And the six-cylinder engine is really kind of simple because it's just three of the two-cylinder horizontal engines anyway. We also have a new two-cylinder inline engine that should be out in about 3 months too.
Wow. And
the reason for that is because we've got people who are planning to use these engines in a thing called, and I didn't even know about this, but it's called a dairy barn cooler.
Never heard of it.
And it's a device that you use in your dairy barn in order to move air and keep it from getting bad.
Okay.
But they need an engine that is in a slightly different format than what we were in, so that's why we're going to that engine. But no, we're not static, but we are involved in all of it. And of course, Plasmic does all of the electronics for every single engine in the world.
Plasmic, Plasmerg. I saw that on your website.
Yeah, Plasmic is a combination of two words, plasma and the engineering term for energy.
Okay.
You got to remember that Inteligentry is actually a merging of two words, intelligent and gentry. And it's gentry because I was originally going to use gentleman, and my wife complained at me and said, no, that's too sexist. But our charge here at Inteligentry is to hire people who are over 65, been kicked out of their jobs or some other thing, and are still productive, so we can go and talk to other inventors who've got ideas so that we can try and help them get to where they need to go.
How can people contact you, John, if they want to be involved with this technology?
www.intelligentry.com.
Okay. I want to thank you very much for your time today, John. I'm really excited about this technology.
And by the way, okay, we invite anyone that wants to talk about this, come out and spend a couple of days in Las Vegas, enjoy life, and come visit us.
I might just do that.
You can come here and visit, and we'll tell you about everything you need to know. And as you can probably tell, we're not exactly closed about anything, so it's the kind of technology that everybody needs to know about. And if they got questions, they ought to be able to get answers for them. And we'll help them out any way we can.
Thank you so much, John. You have a wonderful day, and I look forward to meeting you in person sometime.
Yes, sir. You too. Enjoy life. It's the biggest present you got from God. Meanwhile, have fun.
All right. Thank you. Thank you for listening to the Most Dangerous Device radio show. Until the next time, keep an open mind. Let the light shine in.